Welcome back to Chapter 2, Lesson 2, percents greater than 100% and less than 1%. Now it is time for us to dive into that less than 1% concept. Percents can be less than 1%. Consider the following situation. The distance from the center of the Earth to its surface is known as the radius of the Earth. The radius of the Earth is about 4,000 miles. The radius of the Sun is about 430,000 miles. So, the radius of the Earth to the Sun's radius would be a comparison of 4,000 to 430,000. You can use equivalent ratios to show what the radius of the Earth is. That the radius of the Earth is about 0.93% of the Sun's radius. That's less than 1%. Because 430,000 divided by 4,300 is equal to 100, you can therefore divide 4,000 by 4,300 and round to the nearest tenth. You see that going on right here. They took and said, for this number divided by what is equal to 100? They divided it by 4,300 and it gave them 100. And then they said, all right, then 4,000 divided by the same 4,300 is where they got this 0.93% from. Percents are less than 1% when the number being compared to 100 is less than 1. All right, that makes sense. When the percent is less than 1%, the part is significantly less than the whole. We're talking about very small. The radius of the Earth is significantly less than the radius of the Sun. These are things that we understand. At least I hope you've learned that in science. On a 10 by 10 grid, a 0.93% is represented by shading 93% of one grid square. Wow. Think how tiny those grid squares are and you get to shade 93% of one of them? This ought to be fun. One grid square represents 1% and 0.93% is less than 1%. So let's look at some flashcards here. This is the way you would write 0.93%. You notice they're using the colon, the word 2, and a fraction, but they all mean 93 hundredths of a percent. And if we were to model it, it would look like that. And you can see that in this one little bitty square that they have shaded, they actually have shaded 93 out of 100 little bitty pieces in it. Wow, that's tiny, okay? That's some pretty cool stuff to have to try and comprehend though. So here we have an example of a mistake. The classmate used a 10 by 10 grid to model 0.93%, as you can see here. What mistake did they make? Well, instead of modeling 0.93%, they modeled 93%. They shaded 93% of that square instead of just a 9.93 portion of one tiny little square. So what percent is going to be represented by this 10 by 10 square? And you can see, yes, I know you have an opinion, you can see that they zoomed in on one of the little squares. And inside that one little square, you can count 1, 2, 3, 4, 5 high, 1, 2, 3, 4, 5 wide. That means they have 25 tiny squares shaded inside this one slightly bigger square. So from there, what are we going to do to work the problem? The percent compares the number of shaded squares 100 because the entire grid is 100 squares. From here we can say what less than one grid square is shaded on the 10 by 10, and if we had a close-up to that, we would see that 1/4, also known as 0.25 of that square is shaded, which would make that a 25% of that square, or a 0.25% of the entire one. For our talk about it, a friend states that the percent represented by the 10 by 10 square is 25%. How can you use reasoning to explain to your friend that that answer is incorrect? Well, The real easy part is I'd point out that only a tiny portion of that 10 by 10, one square, is actually even remotely shaded. So that means that it's got to be 1% or less, because only 1% of the big square has any shading in it. Now it's your turn. Pause the recording and put in the answer for this one. Check your answer. Did you get it done? Let's see what I end up getting. I see that I've got less than one whole square shaded here, and in that one square I've got 1, 2, 3, 4, 5, 6, 7 wide by 1, 2, 3, 4, 5 tall. 5 times 7 is 35. That means I've got 35% of 1%. So that is 0.35% of the entire square. Check our answer. Our answer is good. We are almost done. Let's move on to resource number 10 out of 11. The diet of a jellyfish consists primarily of plankton, which are tiny organisms living in the ocean. One species of plankton has an average length of 0.04 inch. Suppose a jellyfish has a length of 8 inches. Write a percentage that compares the length of the plankton to the length of the jellyfish, and then use a 10 by 10 grid to model this percent. Now think about this. Without calculating percent, how does the length of the jellyfish, the plankton, compare to the length of the jellyfish? Well, the plankton is tiny compared to the jellyfish. Now the jellyfish may only be 8 inches, and 8 inches isn't big in our world, but it's a heck of a lot bigger than a 0.04 inches. So let's move forward from there. Use equivalent ratios to show the plankton's length as a percent of the jellyfish's length. Then we're going to drag values over the equivalent ratios here. So let's take a look. We know that the plankton is 0.04 inches and the jellyfish is 8 inches. Now we need to come up with some number that we can multiply 8 by to get it to equal to 100. And I'm going to grab the handy dandy pocket Satan here just to show it to you real easy. If I was to take 100 and divide that number by the 8 we have down here, that is going to end up equaling, where's my equal sign? Right there. That's going to equal the 12.5. That means I have to multiply the top number and the bottom by 12.5. Of course, 8 times 12.5 is going to be the 100. And then we have the 0.04 times the 12.5. Let's go back one, 12.5. And when we do that one, we get a 0.5. So 0.5 is going to go right here. Check our answer. That one checked perfectly. That means we have 0.5% of the size of the jellyfish is going to be how big the plankton is. So now we can come down here. Sorry, the dog just saw a squirrel or something. There's going to be the plankton's length is going to be 0.05% the length of the jellyfish. Check our answer. Oh, I know what I did wrong. I have one too many things there. Let's try that again. So I'm going to go back, get rid of that 0, and check the answer. Now we are good. Let's move on to the next part. Now we need to model 0.5%. So that means we're going to have to shade half of 1%. You got your 10 by 10 grid here, and in that 10 by 10 grid, we're going to shade half of that. And I'm going to have to play around to figure out how to do that. Hold on. Well, isn't this cute? This time, instead of shading the entire thing when you click on it, it only shades half. So you could actually shade multiple halves in here, but why would we want to do that when the answer is only going to be 1/2 of 1%? Hit check the answer, and that is correct. What might be a common error that somebody would make when shading 0.5% on a 10 by 10 grid? I'm thinking a common error would be they would shade 50% of the grid, or they'd shade 5% of the grid instead of 0.5% of the grid, also known as half of 1. little square. Let's move forward. We are on our very last slide, and this one is all about you. Work through the problem, solve the answer, let me know what you get. I would encourage you to show some work on this. We have given you examples of what showing work looks like, and I'm going to give you another example when I'm done here. I will acknowledge that this is a little bit harder than what you've done before. They've not really taught you how to do one that is quite like this. But if you rely heavily on your prior skills, I think you will be able to figure out how to do it. So let's go. We're comparing the height of the real Statue of Liberty and the height of a model. Now it says the height of the replica 2, that means the replica, which is 4.5 inches, let's make that a little bit bigger here, is going to be on top. Meanwhile, the real Statue of Liberty, which is 3,600 inches, is going to be on the bottom. And we have done these in the past where they set it up and set it equal to something over 100. But you know what? That number just isn't jumping out at me. I have no idea what I could multiply 36 by to get it to 100. And even if I did do it, it would end up being some brutal decimal or fraction that I don't want to mess with. So I'm going to work this one a different way. I'm going to put my first number in the house, 4.5 divided by 3,600. I don't need to bounce any decimals anywhere because we've already got them all the way against the wall. This decimal is going to go all the way up. 3,600 goes into 4 0 times. It goes into 45 0 times. Next is going to annex in a 0, goes into 450 0 times. And finally is going to go into 4,500 1 time. You multiply that, you get 3,600. Subtract that out, and you're going to have 900 left over. From here, we're going to annex in another 0 and bring it down. So how many times is 3,600 going to go into 900? The answer to that is going to be twice. And 2 times 3,600 is going to be 7,200. And when we subtract that out, we're going to get a 0, a 0, an 8, and a 1, getting 1,800 here. And we're going to annex in another 0 and bring it down. From here, we're going to take one more time and say how many times is 3,600 going to go into 18,000. Well, for that, I'm going to do my little trick where I scratch out my last 2 digits. I'm going to say how many times is 36 going to 180. And that's a little bit easier to do, but still going to be a challenge. So I would have twice is going to be 72. 72 times plus 36 is going to be 108. 108 plus 36 is going to be 142. Ah, heck, let's just cheat and use a calculator. So for this part here, I'm just curious here. I'm going to take 18000, divide that by 36000. Oh, nope, I did it wrong. 18000 divided by 3600, and that ended up giving me a perfect 5. So I can go back on my grid here and multiply 5, which would give me the same answer here. But this number here is just a decimal. It's not going to be the percent. Remember, to change your decimal to a percent, you have to bounce the decimal 2 spaces to the right, 1, 2. So the answer is going to be 0.125%. With that, I can go back over to my answer key. I'm going to say the actual statue. Oh, that's not the right one. This one here is going to be 0.125. I'm not sure this is going to work. Let's find out. Now we're going to describe the 10 grid that would model it. We're going to shade how much? Half, 1/4, 1/8, or 1/9 of, what's our option here? 1, 2, 3, or 4 squares. So it's going to be of 1 square. Question is, how much of 1 is going to be 0.125? So let's do a little more division. I'm just going to do a handy dandy calculator. We're going to check some possibilities. 1, let's try the 9, divided by 9 equals, that's going to be 0.111. It's not going to be 1/9. So let's take 1 divided by the 8 they offered, and that gives me the 0.125, which I can take and put in right here. Check my answer. Everything did check. Make sure on your homework you're giving me good quality supporting work. You can't just fill in the blanks and not give me something that looks kind of like the work I was doing here, which I should have also added in 0.125 right there. Good luck, work hard, see you tomorrow.